Recently I've been building a voltage-controlled oscillator. Now, I've been building it with a chip called the AS3340. Now, I had the data sheet around here somewhere when I was sticking this thing together, but who knows where it went. But in any case, it's a all-in-one chip that does a square wave output, a triangle wave output, a sawtooth output, and it's a pretty interesting little chip. Now, it's the main brain from a lot of the vintage synthesizers from the 70s and 80s. Korg and Moog synthesizers both use the CEM3340, which is a difficult chip to find and quite expensive, but fortunately a company made a knockoff, the AS3340. So it's it's a voltage-controlled oscillator, a VCO. It will do 1 volt per octave, which is incredible for the price of the package. Now, a VCO in a traditional Eurorack setup can be, $150 to $250 for a single voice, and this project will probably cost about $25, but it'll take, a full solid day to put together. But in any case, I'm going to try and explain the process as best I can and show you what's going on, and we will give it a test by the end of the video, and hopefully I can build this thing without driving myself insane. So far I have the IC sockets and a little bit of the jumper wires and 1/2 of the resistors put on. So, I mean, that's really not much progress in about an hour, and I'm having to pay awful attention to the soldering, and soldering on this strip board isn't exactly easy. These solder joints, they kind of look like crap, but the thing about it is that they look like crap, but if I pull out the jeweler's loop, you might be able to see there is a separation. And as long as everything stays separate, and as long as everything stays mounted, it's really not much of a problem how crappy it looks. So this is just a high-speed clip of me throwing a bit of the parts on the board. It can be pretty time-consuming, and this is only a small portion of the build, and I've actually sped this up to 4,000%. So this is how I spent my evening. This evening was just putting little dots on the board, and everything seemed to work out great, and I didn't have to desolder anything from this entire process. So here we are, ready to run the test on the device. We will see if it operates as intended with the sawtooth waveform. It's the only side that I have hooked up now. So the moment of truth. In reality, I am terrified because I'm not sure if this is going to work or not. So, whew, come on, baby, give me a sawtooth. Oh my, yes, there it is. There's the sawtooth. Yes, it works. Ah, this is so amazing. Okay, so now that I know that the sawtooth works, I can go ahead and I'll wire up the triangle out, and I will test the triangle out here in a moment. And here we go for the triangle test. Oh, that sounds and looks like a triangle waveform to me. Oh boy, so this is very exciting that this project is actually coming together and working in the way that I would like it to. Amazing. I'm so happy right now. I couldn't be happier with the way that this has worked out. Unbelievable. Oh yes, listen to that. Beautiful. So the sawtooth works, the triangle works. So I'm very happy that this project has come along to the point where it is, and there is no sense in stopping now. I'm not going to put this in a case. I'm not going to call it finished. I'm going to keep going, and we're going to see if we can get the square tooth out of it. So here is the board before I'm going to install it on the faceplate. So I'll flip it over and we can take a real good look at everything that needed to be done in the back. Now, as you can see, that's a lot of solder joints, and there's a few mess ups too where I placed things incorrectly here, or I just had to move a bit of solder out of the way because it created a bridge. Now with this cheap, like really cheap strip board, the gaps aren't as far apart as I would like. Now here's the front panel. And I haven't labeled it permanently. I think I'll just leave the tape on it, to be honest. So we've got the pulse width modulation, the coarse tune, the pulse width modulation, control voltage in, the square, the saw, the triangle, and the control voltage in. And this is just like a little bit of plexiglass, or it's acrylic. It's not plexiglass. It's actually pretty difficult stuff to work with and to cut up. But ultimately, I will combine it into the case and we will give it a test here shortly. Okay, so the board is complete. I'm going to put it on the front panel, and I'll just show a little bit of the time lapse of soldering this mess of wires onto this front panel to make it look like something somewhat professional. We'll get this on the front panel and cue the high speed. So as you can imagine, doing something like this is a little bit of a test of patience. Now, fortunately, I chose the path of making sure that all of the wires were individual colors so I could at least keep it straight as to what was going on. During this build process, I made sure to put the heat shrink between the potentiometers because I've had trouble in the past with things getting shaken around and making contact and frying stuff out, and it's never fun to fry something out once you have it all put together.
So here's the test of the device as it stands. Now, it's all put together here.
Ooh, fancy. Now, I haven't chipped the rest of this proto board off yet, but I will at some point in time when it matters. So let's hit the old power supply and see what we got. So, first of all, we'll try out the square wave. And the sawtooth wave. And the triangle wave. And let's head back over to the square and turn on the BeatStep Pro. Let's get the control voltage in. Woo! Beautiful. Let's try the sawtooth.
Well, it seems to work to me, so I think I'll call that a success, and I'll build a couple more. Thanks for watching, and have an awesome day.
So this was interesting. I turned back on the Joe Rogan podcast that I was listening to, and I forgot that I had a
next to the guy
a
who's
splitter
yelling
hooked
out
up so
stupid
I
shit,
could listen to
interrupting the
stuff
show.
and test the speaker at the same time. And here's the oscilloscope of the Joe Rogan podcast just cranking along. I thought that was really funny when I turned it on. So at least I know that having this hooked up to the audio jack is certainly reading the signal that's coming through.
The crowd was going